Good afternoon. Thank you for coming to Microsoft Ignite, and thank you in particular for choosing to come to this session. My name is Cosmos Darwin. I'm a program manager on the high availability and storage team within Windows Server. I'm joined today by Daniel Lee, who's also a program manager on the server management experience team. And we're here today to share with you what's next for managing and monitoring your hyper-converged infrastructure. Now, our outline for today is going to look something like this. First, I'll talk a little bit about hyper-converged infrastructure in general, what it is and why it's so exciting. Then we'll dive into HCI in a Microsoft context, so what technologies comprise our platform and what value it is that we uniquely bring. And then we'll give a demo of Project Honolulu, which hopefully many of you have heard about either through announcements from us or in the press in the last 2 weeks, or in Sam and Jeff's session yesterday. Now, when I say we're going to do a demo of Project Honolulu, what I really mean is we're going to do more than 10 demos with Project Honolulu. We have a very demo-heavy session for you today. Our goal is to spend as much time as we can just using the product up here so that you can see it for yourself. How does that sound? Does that sound like a plan? Great. So let's get started then. Hyper-converged infrastructure. Now, if you've spent any time in the last couple of years, like on the internet, then you've seen these headlines that say things like why hyper-converged infrastructure is so hot, why it's gaining in popularity, that hyper-convergence is in high demand, the need for it in today's business environment, why it will sell like hotcakes. You've seen these rosy analyst projections of this meteoric rise, and you've seen these blogs that attribute all of these great benefits you'll get with it. And if you're like me, there are sort of two things that you get from this. The first is hyper-converged infrastructure is quite possibly the hottest trend in on-premises IT today. And number two, it's kind of taken on this buzzword-like momentum, right? So I think a good place to start is just for us to establish a common understanding of what we mean when we say hyper-converged infrastructure. And to do that, I think it's helpful to start by contrasting it with a more traditional three-tier infrastructure. In a three-tier infrastructure, your first tier is storage. Typically, that's provided by a storage area network or a SAN. You connect to that using a storage fabric. That could be iSCSI or Fiber Channel or sometimes SAS. And then into that, you connect your servers, which if you're virtualized, these are your hypervisors. And probably for most of this room, that means Hyper-V. Now, for certain functions like firewall or network load balancing or data protection and deduplication, you may have some hardware appliances that provide those functions. And then to connect those appliances to your hypervisors and your hypervisors to the rest of the world and your network, you have an Ethernet fabric. Right, so this is sort of if you walk through a data center today, it would be very typical to see something like this in a rack. Hyper-converged infrastructure is about taking those three layers, the storage fabric, and the hypervisors, and consolidating that down into a single tier. And you do that by moving the drives up into the servers as direct attached local storage, and by moving the storage software up into the hypervisor. So what you're left with is your Ethernet switches. Of course, we haven't done anything to get rid of those. And then industry standard x86 servers with local drives and the magic of software. Now, this architecture has many advantages. First and foremost, it allows you to lower costs because you're getting rid of proprietary hardware. I mean, things like fiber channel switches or cables, those are not cheap. You guys know this. You're getting rid of vendor lock-in, and in its place, you have choice. Your choice of any x86 server and component, which means you're getting the economics and the scale and the competition of the server market working for you. And as we showed, very often switching to a hyper-converged infrastructure results in having a smaller data center footprint, which means less power, less cooling costs, and less operational costs in general. In addition, hyper-converged infrastructure allows you to innovate faster. I don't know if you all know this, there are 100 times more servers sold every year than storage arrays. What that means is that the latest innovation, whether to you that means NVMe or remote direct memory access, RDMA, or storage class memory, it is coming to x86 servers first, and in many cases, to Windows first. That's why we're switching Windows Server from our usual release cadence, which was every 2 or 3 years, toward a semi-annual cadence so that we can deliver these innovations to you even faster. And if you want to try them out even sooner than that, you can, and I encourage you to join the Windows Insider program. Now, in addition, hyper-converged infrastructure allows you to scale out more easily. So customers tell us that with that traditional 3-tier architecture, what they end up doing is trying to forecast what their capacity needs will be 3 and 5 years out, and then buy what they think they'll need up front, which is a huge, very real capital expenditure. With hyper-converged infrastructure, you can instead buy what you need today, and then scale out or scale up, either by adding drives or adding servers, and you can add them one by one. Now with Windows, we have built-in storage and compute load balancing. So when you do that, when you add more drives or you add more servers, we will automatically redistribute your VMs and your storage across all of your hardware. Thank you, Daniel. Which makes capacity planning a breeze. Now, because you've consolidated those 3 tiers into a single tier, you can often buy hyper-converged infrastructure from a single vendor. So you can go out and pick your favorite OEM, whether that's Lenovo or Dell or HP or whoever it may be, and you can buy hyper-converged infrastructure from them. And then that gives you a single source for procurement, and more importantly, a single point of support. So there's no more of that where you call one of your vendors and they pass the buck to somebody else and you end up playing phone tag. That doesn't happen anymore. And last, but not least, customers should and do expect a unified management experience with end-to-end visibility from the compute all the way down into the storage. And if I'm honest, this is probably the area where we haven't delivered as Microsoft as well as I would like. And so our goal for today is kind of to show you that we are investing heavily in that going forward and to encourage you that we're on the right path. Now, given all of these advantages, it's not surprising that hyper-converged infrastructure has seen incredible growth. According to the most recent numbers from IDC, which are just from last month, the current rate of growth for hyper-converged infrastructure in 2017 is over 65% year over year. And that's against the backdrop of an infrastructure market that is growing in kind of single digits, right? So it's just taking over. Okay, so that's hyperconvergence in general. What does hyperconverged infrastructure mean with Microsoft technology? Now, a question that we get often, and actually I should tell this story. So sometimes customers will come and they'll visit us in Seattle, and usually it's IT decision makers or CIOs. And I had this experience recently where a CIO was visiting, and it was from like a big household name store. It's like where you go and buy stuff on the weekend. And this person shows up and they say, hey, I'm a Hyper-V shop. What do you have for hyperconverged infrastructure? Tell me you have something. And the answer is yes, of course. You have come to the right place. Hyperconverged infrastructure in the context of Windows Server is really 2 technologies, our standard offering. Hyper-V, which I imagine this room is quite familiar with, and then Storage Spaces Direct. Now, Hyper-V it was introduced in 2007, which, by the way, means this is the 10 years. And it's the foundation, as probably you know, of our hyperscale public cloud, Azure. So you guys know Hyper-V. You could be forgiven for being less familiar with Storage Spaces Direct. It's new in Windows Server 2016, but it's been in development at Microsoft for over 5 years, and in use by us at Microsoft for nearly 3 years. And I don't know how widely known this is, but it's the foundation storage layer of Microsoft Azure Stack as well. Okay, so a little bit, just a small taste about Storage Spaces Direct. It offers industry-leading performance. Last year at Ignite, we demoed over 6 million IOPS from a single Storage Spaces Direct cluster. We also demoed over 1 terabit of throughput, which we said at the time was the equivalent of reading English Wikipedia 10 times every second. And we did all of these demos with consistent sub-millisecond latency. We are not aware of any other storage platform on the market that even can do half as much performance. So we feel very good on this front. But performance isn't everything. Storage Spaces Direct also has all of the enterprise-grade features that you expect from enterprise-ready storage, whether that's the ability to tolerate drive failures, server failures, network failures, even rack failures. With approaches like software RAID, we can do distributed software RAID 1, RAID 5, RAID 6. We have built-in checksums to protect against single-bit errors. We have data encryption for data at rest and in transit. We have a kernel-embedded architecture that supports remote direct memory access. We have data deduplication and compression and in-memory cache, a persistent read and write cache, real-time tiering, the ability to support hybrid or all-flash configurations. And I could go through this list for an hour. And actually, that's what I'm going to do on Thursday. So if you guys are interested, you should come to session 3144, where we will walk through all of those different features of Storage Spaces Direct. But suffice it to say, it's a storage platform that we're quite excited about. Now, one additional point that I think is very important is that Storage Spaces Direct is included in Windows Server 2016. You do not need a separate license. You do not need to buy a separate SKU or install anything separate. In fact, if you run Hyper-V at scale, you probably already own this today. It's basically as free as our business planning people would let us make it. So, OK, how do you procure hardware for Storage Spaces Direct and for hyper-converged infrastructure on Windows? There are really two approaches. The first, of course, is you can build your own. We have a strong heritage of DIY with Windows Server. It's something we're very proud of. It's something we embrace and absolutely support. So to do this, you can pick any components off of the Windows Server 2016 catalog. They just have to have passed the software-defined data center additional qualifiers. But as of this summer, there are more than 1,000 components that have passed all of those qualifications. So this is really your most flexible option. The other thing you can do, and honestly, this is what I would do, this is what I recommend, is you can take a solution that's been pre-validated from one of our partners. We've been working for the last few years with all of the big server OEMs. We've built a reference architecture, which we shared with them. They've come to our campus many times. We've run hundreds of hours of exhaustive stress tests against these systems. And we've developed these pre-validated solutions that are really the quickest time to value, and they'll give you the best experience with the least risk. And so we have 7 initial partners that have been working with us. Together, they represent over 70% of the x86 on-prem server market, so very likely whoever your preferred hardware vendor is, their logo is on this slide. And we're working with many more OEMs and bringing more online all the time. This gives you an example of one server SKU from each of these OEMs. Every one of them has multiple versions. They all have at least one all-flash and one that contains hard disk drives, and many of them have quite a few different configurations. So if you'd like to learn more about these pre-validated solutions, you can go to microsoft.com/WSSD for Windows Server Software Defined, or I should say perhaps my colleague Subodh is going to be giving a session that's all about the Windows Server Software Defined program called The Fastest Route to the Benefits of Hyper-Converged Infrastructure. And if you want to hear all about it, you can go see his session. Now, one last piece that I think is really important about our partnership with these OEMs to develop these pre-validated solutions is we've worked with them to create a scripted deployment workflow. And so this, leveraging PowerShell, which is one of our great assets, we can automate every single step of the deployment, completely standing up an environment from just bare metal to being ready to go. Now, I don't think anyone really enjoys those next setup flows. This also is, because it's perfectly repeatable, it reduces errors, and it means that every environment is consistent. OK, so suppose you buy one of these solutions, your gear is all here, it's all set up. How do you manage and monitor it? How do you do those, what sometimes people call day 100 scenarios? And that's where Project Honolulu comes in. And to tell you more about that, I'd like to hand it over to Daniel.
Thank you. How many folks here have been to yesterday's session on Project Honolulu, or you've downloaded yourself, tried it out, have a good understanding? All right, good. The new hyper-converged menu experience is built on Project Honolulu. There's a lot we want to show today, so I won't go into too much detail on Project Honolulu, but for the folks that are not familiar with it, I'll just talk a little bit about Project Honolulu. What is Project Honolulu? Project Honolulu is a next-generation server management platform for Microsoft. Think of it as a replacement for the Server Manager and MMC tools, the tools that you're familiar with, Event Viewer, Registry Editor, Device Manager, all those, but also providing an enhanced experience for scenarios like Hyper-V, Storage Spaces Direct, and hyper-converged, as we'll see today. Project Honolulu is web browser-based. We've currently tested it on Edge and Chrome, and we plan on expanding that in the future. Project Honolulu, even though it's web browser-based, we do not rely on an internet connectivity. You can install Honolulu on premises and does not require internet connection or dependency on Azure at all. Project Honolulu is in public preview, techno preview. We announced this just last Friday, so this is all very new, and we're just getting started. All right, let's start with our first demo, installing Project Honolulu. You might have already seen this. I'll start a stopwatch to see how long it takes. If you go to ak.ms/Honolulu download, this will take you to the Windows Server Evaluation Center. Since this is a technical preview, we ask you for a little bit of your information. We promise we won't spam you or sell your information anywhere. If you click on Continue, then you can actually download the installer MSI file. You can see that it's just a small 32 megabytes. And we'll ask for the HTTP port that Honolulu will listen on to serve you the web pages. Project Honolulu can be installed on Windows 10 and Windows Server 2016 without any prerequisites at all. There's nothing that's required on the target servers you're trying to manage either. It's all just a clean installation of Windows Server, Windows Client, and you can get it up and running. Once the installation is complete, you can close it down, go to the Windows Start menu, search for Honolulu, and Honolulu will open up in your default web browser. There's a friendly tour, but we'll skip that for now. And this is the Honolulu homepage that shows you the servers and clusters that you want to manage. In order to add a hyper-converged cluster, you can click on Add. You can choose to add a server, a failover cluster, or a hyper-converged cluster. In this case, we'll go with hyper-converged cluster connection. Type in the fully qualified domain name of your cluster. And you can see that we validate the name with your credentials. And I'll also give you an option to add the cluster nodes to manage through Honolulu as well. Now the servers and the clusters all added, and you can see that we attempt to connect and show that they're all online. And now, in under 2 minutes, in just 2 minutes, you're up and ready to start managing your hyper-converged cluster. So this is a web UI. You might be thinking, what else is required? Do I need SQL or IS? How does this work? So quickly, if you install Project Honolulu on your Windows 10 laptop, then it'll listen to the HTTP port and serve web pages to your browser. And then Honolulu will go out and connect to your servers with remote PowerShell and WMI over WinRM. So if you've connected to your servers with remote PowerShell WMI before, then this should just all work automatically. No additional configuration required, no additional ports to open, and no additional firewall rules that need to be enabled either. You can also install Project Honolulu on a separate server, Windows Server 2016, and then remotely connect from your web browser, from your laptop, to the Windows Server. And then you can also share the connection, the Windows Server, the Honolulu installation with other IT admins in your organization. That's all for today on Project Honolulu. If you missed yesterday's session, I highly recommend that you go and check out the recording. All right, well, let's move into actual hyperconverged stuff. Let's look at our first dashboard demo. And if you go back and click on the hyperconverged cluster, this is the overall dashboard of your entire cluster. You can see alerts on the top left. We show alerts from the cluster health service aggregated from the entire cluster. We show you performance metrics for cluster IOPS. We're seeing a good, healthy 678 kilo IOs per second. Latency charts and throughput. And you can see that this is for the entire hour. And you can hover over the actual data points on the chart to see the timestamp and the value of each point. This is all collected and aggregated on the cluster itself. You can switch over to day, week, month, or up to an entire year and see all that data in time. If you go to the bottom left, there's CPU, memory, and storage resource consumption, again, across the entire cluster. And to the right of that, you see the top-level objects that are most interesting to IT admins. You see that we have 3 servers. They're all in a healthy state. Drives, we have 18. They're all good as well. And you see that we have 17 virtual machines, 14 running, 2 paused, and 1 off. We see the different states, and 12 volumes. And you can see that one of them is actually in a warning state, and one is in a critical state as well. I also want to point out that these objects that we just went through, they're also in the left-hand menu, showing dashboard, drives, servers, virtual machines, switches, and volumes. And I want to point this out a little bit, because this is an important part of our overall design. We looked at the experience, the workflows of using existing MMC tools. And for this example, I'll use Hyper-V as an example, but this is the same problem we have across all our tools, all our technologies. If you wanted to look at the event logs for a virtual machine, then you would remote into a server, bring up Event Viewer, look for the Hyper-V channels, and then look for the VM ID, and then you finally get the event logs for VM. If you want to look at VM perf metrics, then you launch Performance Monitor, look for the Hyper-V counter sets, and then look for the VM instance, and then you get your virtual machine metrics. If you're interested in VHD metrics, then you bring up Hyper-V Manager, look for your VM, look for the VM settings, and find the VHD path, and then go back to perfmon to look for the VHD metrics. And we noticed that everything is centered around tools. You launch a tool, you tell the tool that you're interested in Hyper-V, that you're interested in a certain VM, and then you get your events. You want to go to metrics, you go all the way back, launch another tool, tell them that you're interested in Hyper-V, in a VM again, and you go back to Hyper-V Manager and do the same thing over and over. And we realized, like, this is really repetitive. It's a lot of unnecessary steps. How can we do better? So if we remove the artificial boundaries of tools, and you're going to a VM, like Hyper-V, that's not necessary either. Let's get rid of that as well. And if you center things around objects like servers, virtual machines, and VHD files, and then tie the events and metrics, the health, around VMs and these objects, then the map becomes really simple, right? Look at the number of edges compared to our previous one, right? And then, if we focus on these objects and the relationship and expand this to compute, storage, and networking, we come up with a map like this, right? This is important because when you're troubleshooting, the relationship between these objects is important, the way that you connect the dots, because a virtual machine problem could actually be a VHD problem, which turns out to be a volume problem, which actually turns out to be a server or drive power problem. And this is something that in the demos that we show, we're trying to tackle this problem and provide a solution for this. All right. Let's look at what the Hyper-V experience in HCI looks like. Customers have told us Hyper-V is great. It has all the new features, all the new technology we need. Hyper-V is not the problem. Hyper-V management is. If you go on Windows Server User Voice and look at the Hyper-V section, #1 request is new integrated UI for Hyper-V, bringing Hyper-V Manager and Failover Cluster Manager together. #2, change how Hyper-V Manager creates VM folders. Instead of having a separate folder for VM configuration files and VHD files, put them in a single folder so they are easy to manage. Show IOPS for Hyper-V. And show performance charts for CPU, RAM, and network usage with historical diagrams. Keep this in mind because we'll be tackling these problems in the following demos. Let's see the Hyper-V UI in action. If you go to the virtual machine menu on the left side, this is your summary view of all your virtual machines. And you can see alerts. They're all filtered down to just so the VM alerts because you're in the context of virtual machine management. Down below, we have the same donut charts you saw on the dashboard, but now they're broken down to show host versus guest usage, so you know how much the host is using and how much the guest VMs are using. Next to that, we have the top VMs consuming resources like CPU and memory. And down below, we have performance charts for IOPS and IO throughput. Now, if you're in Hyper-V admin, you probably had to look at event logs at some point. Let's see what that's like in Honolulu. If you click on the View All Events link, this is the event viewer tool in Honolulu for standalone server integrated into the new hyper-converged experience. You can see that it's not the entire list of channels. It's just the Hyper-V channels because you're in the context of virtual machines. That's all you need, right? You can quickly find the channel that you're interested in, expand that, get all your events, click on event, and you get the descriptions at the bottom. You can switch over to see the details. Pretty fast, pretty slick, right? But that's not it. If you look closely, there's a machine column. If you can see the server -25, -24, and -27. So we're not just bringing in events from a single node. We're actually going out to all 4 nodes, collecting them, and showing that to you in a single view. Using Event Viewer MMC, remoting to a computer and getting these for a single server is like 8 steps. On a 4-node cluster, do that times 4. That's 32 steps. And here, we're bringing that to you in just a few clicks. This is the beauty of Honolulu. This is where Honolulu really shines, being able to bring all the tools you need for troubleshooting, management, monitoring into a single experience. Now let's go back to virtual machines and look at the inventory. If you switch to the inventory tab, this is a list of all your VMs across your cluster in a single view. Hyper-V Manager, Failover Cluster Manager, all in a single experience. You have the VM name, state, which host server it's running on, whether it's clustered or not. And next to that, you have nice bar charts showing color bar charts for CPU and memory usage. If you click on one of the VMs, then you have the familiar commands: turn off, shut down, save, pause. In the more dropdown, you have reset, checkpoint, VM settings. Let's try and move a VM. You can choose which cluster node you want to move it to. Hit move. And then you get a toast message that we've started that process. And we don't want you to be staring at this, waiting for it to complete, because it's going to take a few minutes. We have a notification pane, the bell button at the top, which will track long-running jobs for you. So you can go off, do other things, come back anytime. You'll see where we are. And at the end, you'll also get a toast notification that the move is complete. If you scroll down, you can see that the VM has actually been moved to server -27. Now let's drill into a single VM. You click on a VM name, and then this is the view for a single VM. You get all the properties you expect in Hyper-V Manager. And below that, you have performance charts for CPU, memory and network, IOPS and IO throughput, live charts that are updated every few seconds, and the same charts for historical charts, hour, day, week, month, and up to a year. You ask for CPU, memory, network charts, IOPS storage, historical charts, all here in a single view. And down below, we have checkpoints nested as you would expect with the familiar commands you need. And below that, we have VHD files, and then showing you the VHD connect to the VM, and then networks showing you the virtual NICs and the server, the host server that the VM is running on. And you can see that this is still work in progress, but you can see that we're starting to connect the dots, bring these together, tying the related objects together so that you can click, in the future, you'd be able to click on a VHD file to go to a single VHD page showing the VHD metrics, the VNIC page to see the information on your VNICs, and jump into the host server to troubleshoot server problems for virtual machines. And by the way, all the Hyper-V UI that I just showed you, it's available and supporting Windows Server 2012, 2012 R2, 2016, standalone servers, and Hyper-V clusters as well.
OK, thanks, Daniel. So Daniel showed you what we've done with Hyper-V Manager in Project Honolulu. But of course, that's only half of the hyper-converged infrastructure story. We also have storage management that we need to talk about. And this is exciting to me, because this is something we've not had before. So if we start from the same dashboard, I'm going to go and I'm going to look at the server's view from the navigation. Now, this should look a little familiar, because it's very similar to the page that Daniel showed for virtual machines. I can see how many servers I have. I can see them grouped by their health status. If there were any alerts that I needed to know about, I would see them here. And just like Daniel did with virtual machines, I can switch over to an inventory view, a list, where I can see my 4 servers, and if I want to, I can click on a particular one and drill in. So here's a page for one of those servers in the cluster. This is one of the Hyper-V hosts, right? I can see things like who manufactured it and the OS build, including that cumulative update number, which we've made obvious now. I can also see CPU usage. Here we're breaking it out by host OS usage in the hypervisor, as well as virtual machine guest consumption. We're giving that same breakdown for memory as well. And I can see the network activity that this host is driving across all of its physical network adapters, and we've broken out that remote direct memory access traffic, so you can see that easily as well. Continuing down the page, here I have a list of all of the drives that are inside of this server. Now this is, I said, a Hyper-V host, but of course it's hyper-converged, and what that means is we've taken a bunch of extra local storage and connected it direct attached into this server so that we can use storage spaces direct. So you can see I've got quite a list of drives. I have 4 SSDs in this server. Those are being used to provide caching, and then all of these HDDs are providing capacity. So the SSDs for cache, what that means is they're being used to accelerate I/O, but they're not actually providing me storage capacity, which is why I don't have a gauge for how full they are over on the right. The HDDs, on the other hand, they absolutely are providing storage capacity, and so I have that gauge and I can see how full they are. Now, that's a view of the drives within one server, but there's this other view as well, which is you can just select drives all up from the navigation, and you get a page that looks very similar. So you can see how many drives you have in total. This is sort of the storage pool view, if you want to call it that. You can see, again, them grouped by health status, any alerts that you may have. And just like with servers or virtual machines, you can switch over to inventory and get a big table. Now, with drives, because we have so many of them, we can do some pretty interesting things in this table. So for example, we can group by host server. And then I can see my big list of all my 64 drives, but I can see very clearly which ones are in the server 24, which ones are in 25, which ones are in 26, and so on, right? This is a very powerful, rich control that we've built here. I can see that in each of my servers, I have the same configuration. I have a bunch of SSDs and then some HDDs. And I can even group by something else, like type if I wanted, and see that even more clearly. I can see all of my HDDs and then all of my SSDs separately. This is just to give you a feel for sort of how navigating this works. Now, just like with servers, I can select a particular drive and drill in. So here I'm on a page that's just for this drive. I can see properties like its location, what slot is it in, and even some pretty deep information like what firmware version is it running in case I need that. I can also see statistics that are specific to this individual drive, so IOPS, latency, and throughput. And at this level, we're breaking those out by read and write, just in case that helps you with whatever it is that you're trying to troubleshoot or figure out. Just like on the dashboard, these charts are totally interactive, so I can mouse over and get particular timestamp value pairs. And I have that history that's being recorded automatically for me, so I can switch back to a day view or a week view. And by the way, we record this history even if you close Honolulu. We're recording this on the cluster. So I can get that same experience that I have on the dashboard for each individual object in my environment. At the bottom, just to round out the page, we have that link back to the server. We talked about connectedness. This is one of our big design goals. And so just as I could jump from the server to the drive, I can jump back. And there are actions at the top. So if I don't like what I'm seeing, I don't know, maybe the latency is high or something, if I want to retire the drive, I can just go up and click a nice handy-dandy retire button. What that'll do is tell Storage Spaces Direct to stop using this drive. Now, in my case, I don't actually want to do that, so I'm going to hit close. But if I did, it's very easy, and Windows will automatically start evacuating all the data off the drive, and then I can just go and replace it. One more thing to talk about with drives is if I switch back to the summary view, you'll see here I have this capacity gauge, which shows me across all of my physical storage hardware how much raw capacity I have. And if I had multiple types of media, like if I also had SSDs, I would have multiple bars on this page. But in this case, I just have HDDs providing capacity, but I can see how much capacity I have, how much is used, how much free space I have, and so forth. OK, now in this case, I have some free space. So how do I make use of it? How do I turn this raw storage with Storage Spaces Direct into something useful? And the answer there is volumes, which are their own tile on the dashboard. I can also get there by switching to volumes in the L2 navigation on the side. Here I see a view. Hopefully you're starting to see the paradigm and the familiarity. Here I have a view that shows me how many volumes I have, any alerts, And just like on the other pages, I can switch over to this inventory view and get a whole list. Now here I can see all of the volumes that I've created, that I've carved out of that storage pool. I can see properties like their resiliency, three-way mirror, or the file system. In this case, they're all using REFS, the resilient file system, which is our recommendation for virtualization. Now, creating a volume is actually super easy. I just go up and click this Create Volume button, and that action pane will fly out on the right-hand side. I only have to put in a few fields. I have to give it a name, like demo. I have to pick a size, like, for example, 1 terabyte. And then I have a couple of choices for resiliency. Now, in this case, I'm going to stick with the default, which is three-way mirror. And what that means is for any data that we put inside that volume, I'm going to create 3 whole copies of it, and I'm going to distribute those across the drives and across the different servers in my cluster to provide fault tolerance. Now, the trade-off that I make with that is that because I have 3 copies of everything, my 1 terabyte volume is actually going to require 3 terabytes of physical space. But that's OK. I have plenty of space. So I'm going to go ahead and click Create. Now, very similar to what Daniel showed earlier, I can track the progress of this by going up to the little bell in the top corner, and I can see that my new volume is being created. And when it's done, it'll appear in the list on the page. And during that time, I could go get a sandwich or do whatever I want. Now I can drill into this particular volume, see a page for it with a bunch of actions. I can see those properties I mentioned, like the file system, the fact that it's a 1 terabyte volume, the fact that because it's using three-way mirror, it has a footprint of 3 terabytes. And I can also see some other properties that didn't make the inventory view, like the fault domain awareness, which in this case is set to server. What that means is those 3 copies I mentioned are going to go on separate servers so that we can tolerate not just drive failures, but also server failures. And I can also see the path, the file path, C cluster storage volume name, demo. And that's where we're going to put our files so that they're in this volume. And we'll show that in just a minute. OK, now just to round out kind of the lifecycle management story for these volumes, I've created a volume for myself called Resize Me. Probably see where I'm going with this. I can, on the individual volume page, click this nice new resize button. It'll pop out the action pane. And all I have to do is type in a new volume size, and we'll automatically expand the REFS file system to fill up that additional space. So I can pick, say, 2 terabytes, which means its footprint will be 6. Just like with creation, I'll get a notification that tells me it's running. And once it's succeeded, I'll see those properties update on the page. And all of these actions, of course, are non-blocking, meaning you can continue to do other things in Honolulu while these are running, which is a huge improvement over what we have before. Last but not least, OK, so I showed creation. I showed modifying. The last thing is, of course, deletion. Deleting a volume is super easy. I go in, I click the delete button. It gives me a little warning that says, hey, this is going to erase all your data. And I'm like, yes, I know. So I'll click the checkbox, hit delete, and just like that, it's gone. So volume management, and in this case, these are, of course, storage spaces, right? We've really tried to make that as simple as we can inside of the hyper-converged experience with Project Honolulu. OK, so we created a volume in there, a 1 terabyte volume called demo. And we haven't put anything in it yet. It's empty. So to make use of it, I'm going to give it back to Daniel.
All right. Let's look at the Create VM experience in Project Honolulu. You're back at the VM inventory page. If you click on New, this is the single pane you need to fill out to create a new VM. Let's give it a name. You can choose Gen 1 and Gen 2. You can also choose which host you want to place it on. We see all 3 nodes. And then one of them is actually recommended. This is using a new cluster API in Windows Server 2016, the same API that Azure Stack is using for host recommendation. Down below, we have a paths dropdown that shows you all the cluster shared volumes across the entire cluster, along with the space available for each, so making it easy for you to choose which volume you want to place the VM on. We'll go with the demo volume that we just created. You can choose how many virtual processors you want for that VM, and also dynamic memory. You can change the dynamic memory. Note that we're not using megabytes anymore. We're using gigabytes, so you don't need to multiply by 1024. And for this demo, we'll create a new VM from scratch and use a Windows Server DVD ISO file. If you click on Browse, then it'll bring up the web-based file picker. You have a breadcrumb bar at the top. If you click on C, then you can go to the root folder. Double-click on cluster storage, brings you to the list of CSVs. We'll scroll down. You have multiple pages if it's long list. And then let's choose our ISO file. Now click Create. You'll get a notification that it started. And we're done. And in a few seconds, if you go down and look at the list, then you actually have the VM in a stop state. Now let's try starting that one. You get the toast notification at the top. At the bottom, you can see the VM is now changed to running state. And now we just created this VM, so in the real world, you wouldn't do this. But let's go and create a checkpoint for this, because there's something I want to show you. We'll give it a name. Create a checkpoint, fast forward a little bit, then the checkpoint is created. And now let's switch over. I have another tab with Project Honolulu opened with a standalone server experience. You can see that we've navigated in File Explorer to the same cluster storage folder. You go in to the demo volume, there's a Hyper-V folder, and underneath we have a folder for that VM that we just created. And look, the snapshot files, the virtual hard disk files, the virtual machine configuration files, all in a single folder. All your snapshot files that you will expect, the VHDX files and the checkpoint files, the AVHDX files are here as well. And the virtual machine configuration files, all in a single folder for you to make it easy to manage, just like you asked for. Now if we switch back, let's try and finish installing the OS on the VM we just created. If you click on the Connect button, then it's going to start downloading an RDP file. And you might be wondering, like, the OS isn't even installed. What are you going to do with an RDP file, right? But there's actually a configuration in RDP to do RDP to the VM Hyper-V host and then do VM connect to the guest. So you see this is pre-OS installation screen, but we're showing that in remote desktop window VM console. You can see that you can finish completing the OS installation. How many folks knew that you could do that? Pretty cool, right? All right, back to you.
Yeah, thanks, Daniel. OK, so with this next demo, I want to take us back to basics. Why are we doing this, right? Why are we creating a cluster? Why are we using storage spaces direct? And some of my colleagues might take issue with this simplification, but at the end of the day, it's about fault tolerance, right? It's about we want to be able to tolerate a drive or a component or even a whole server failing, and for our applications and VMs to not really notice. So that's what we're going to demo now. So just to set the stage, I've gone ahead and resolved all of those different alerts that we had in previous demos. So now we have a completely clean, the dashboard is just all green, it's all goodness. There's nothing wrong yet. Now, in this C cluster storage demo folder that Daniel was just using, we're going to upload a file that's just going to serve as kind of a canary for us. So I'm going to upload ninjacat-trex.gif. And the whole point with this file is just that as long as we can access it, then we know that the storage is up. Obviously, it's not the file that matters. The files that really matter are Daniel's VM. But this GIF, it's fun. OK, so now we get to go kind of chaos monkey on our storage. So if we take a look at our cluster, this is the cluster we've been using for all these demos so far. We have a 4-node hyper-converged cluster. And if we kind of break these layers out so that we can see inside, what we have is a bunch of SSDs and a bunch of HDDs in each of these 4 nodes. So the first thing we're going to do is simply fail a drive. In my case, I'm just going to do it by pulling it out. It's the easiest way to see how the scenario goes. So how does this look on the dashboard? Well, from the dashboard, actually, it's very obvious. So up here, we have those alerts, that alert area. It's been empty so far. Here, now we have an alert that says Windows cannot communicate with the drive. And actually, down in the drives tile, I can pretty clearly see that one of them, it's not a green check mark anymore. One of them is in a red critical state. If I pop open that alert, I can see the text of it. I can see that, hey, the drive may have failed. Maybe it's just the connector is loose. We give you this nice explanation. I can see the server name and the server serial number, so I can go find this drive. I can see the slot position of the drive in this alert. And I get this recommendation that says, hey, you should go check if the drive is properly connected and working. If I want to do that, I have this nice handy Go to Drive button that will take me directly to the page for the object that originated this alert. I can see that its status is lost communication, which is not surprising because I pulled the thing out. And I can see that the performance statistics have clearly stopped at some point recently, right? So this drive there's nothing going on here. It's dead, Jim. And if I choose to replace it, I can go up and click that nice handy-dandy turn light on, and that will go turn on the indicator LED on the drive so that I can go into my data center, easily find it. And as you've probably heard me say many times by now, with Storage Spaces Direct, drive replacement is just plug and play. So I pull out the drive that I want to replace, I insert the new one, we will automatically discover it, begin using it, forget about the old one, move data onto this new drive. I don't have to do any of those steps myself. It's just I pull out the old one and put in the new one. Very easy. OK, so that's a drive failure. What about a failure of an entire server? What does that look like? OK, so this one's actually easier to fake. You just like pull the plug and it goes off. So that's what we did. And how does that look on the dashboard? So back on the dashboard here, we can see that where I had that one alert for the drive, I now have a second alert with higher severity. It's a more urgent problem that tells me, hey, this server cannot be reached by other servers in the cluster. And I could click on it, and I could get all of the same alert text and so forth, and I could go to the server from that button at the bottom. But I don't want to do that right now. I'm just going to close this, because I want to draw your attention to something that I think is actually a little more fun and interesting, and that is that all of the volumes are still marked as healthy. Now, there's a nuance here. They're not perfectly healthy. They need to resync, because we're doing workload while this is all running, so they're getting a little bit out of sync now. But they're all still totally there. I can browse them. I can click on one and go in, and I can see it. And most importantly, if I open this volume in the File Explorer tool, I can still read all of my data that's there, including NinjaCat T-Rex.gif. And we can, in Honolulu, we can download that file and take a look at it. And there's our NinjaCat T-Rex.gif. Right? And that's really the whole point of this whole cluster, this whole Storage Spaces Direct, is that even when you have a drive failure or a server failure, or even multiple concurrent failures, all of your data remains accessible, right? It stays up. That's the whole point. And this is a demo that we wanted to do to really convey that and show it to you, show you how that looks on the dashboard. OK, now something that I mentioned earlier when I was talking about the advantages of hyper-converged infrastructure, I mentioned hardware innovation. Because there's so much to be excited about. There's so much of it, and it's coming so fast. And in so many cases, whether we do the light up for Xbox or Windows 10 or Azure or Windows Server, that innovation is available on Windows first. Now, whether you're talking about storage class memory or Intel scalable Xeon processors, codenamed Pearly, or NVMe SSDs connected directly to the PCI bus, including, by the way, Intel Optane SSDs, which are using 3D XPoint as a media, or RDMA, Remote Direct Memory Access, which is an exclusive to Windows in the software-defined storage space. No other platform has RDMA right now. Or even Thunderbolt, where we're pioneering using Thunderbolt as an interconnect for servers. All of these are examples of the exciting hardware innovation in the x86 server space that you can enjoy with Windows Server, and that I'm going to be very candid. I mean, this hardware innovation for your data center, it's not going to come in a SAN or NAS array. It's just not. So we wanted to give you a demo, a little sneak peek here of something that we think is truly revolutionary, and that is using DIMMs, using memory, using DRAM as persistent storage. So one of the announcements that we've made at Ignite this week is that storage class memory support for Storage Spaces Direct is available to Windows insiders effective today. So how does that look in Project Honolulu? OK, from the dashboard, I'm going to show you around this little cluster we have. It's a 6-server cluster. I'll switch over to the inventory tab so that I can show you those nodes. And I want to give a shout out to our friends at HPE who were kind enough to lend us this system. It's Proliant DL380 Gen 10s. It's the latest they've got. And if you take a look at the drives that are in this system, we have, yes, a bunch of SSDs. But in this system, those are the slow drives, because we also have a bunch of storage class memory down here, which is persistent storage that is as fast as memory. And in this case, we're using it as capacity, but you can also use it for caching if you'd like. You can drill in and see the same drive page. Here I'm not doing any workload, but we have all the same statistics, all the same experience around these devices. And you can see actually the location of this device. It's in a DIMM slot. This thing is a stick of RAM that we are using as persistent storage. Now that's just a very small teaser of what this looks like. If you'd like to learn more, you should go check out my colleague Klaus's session, which is on Thursday, where he'll be talking a little bit more about this revolutionary hardware innovation. And you can also swing by HPE's booth on the expo floor. They recently released, I think they have a solution brief there, where they talk about the performance they were able to get with it with SQL Server. The numbers are pretty incredible, so I encourage you to check that out. Now, another thing that I talked about at the beginning for why hyper-converged infrastructure has so many benefits is not just hardware innovation, it's not just lower costs. It's also that you can scale out easily as the needs of your organization grow. And I'd like to show you that. So in particular, I want to show you self-balancing compute and storage, which are both things that shipped in Windows Server 2016. But with Honolulu now, we have this new way that we can show it to you. I think this is my favorite demo. It's got a time lapse in it. I'm just excited. OK, so I want to show you around first the cluster that we're going to use, because it's a different cluster from what we've been using before. It's very small. In particular, we have just 2 servers. And in each of the servers, we have just 6 drives, so 12 total. We're still running a handful of virtual machines, but it's a really small cluster. And actually, that's kind of, therein lies the problem. If you look at my CPU usage on this little 2-node cluster, it's over 50%. Now, ideally, I don't want that, right? I would like for all of my workload to be able to fit into 1/2 of my cluster if I need to. That's kind of the whole point, right? It can fail over. So I'm going to need to deal with that. And that's going to be what we're going to do in this demo. Now, just to show you around, here are those 2 nodes. They're numbered 3 and 4. I can also show you the drives, because again, I love these tiny little clusters. We have one, I have one in my office. It's an all-flash cluster, so it's got, again, just 6 drives in each of the 2 nodes. I have 2 NVMe, which I'm using as cache. And then I have 4 SSDs, which I'm using as capacity. This is our minimum. By the way, this is as small as you can go with storage spaces direct. And I have the same thing in the other server as well. So if you group it by cache or capacity, you see I have 4 cache and 8 capacity. Just to complete the tour, I'll show you the virtual machines as well that we're running on this cluster. So I'll go back over into Daniel's virtual machines area here. You can see them all. It's actually the same VMs we were running before on the other cluster. And if I take a look at the host server column, I can very clearly see that about half of them are on node 3, and about half of them are on node 4. And actually, with this table, I can sort by that column, for example, and I can see that pretty clearly. I can see that I've got a bunch of them on node 3 and a bunch of them on node 4, which is my other node. OK. Now, with hyper-converged on Windows Server, you can scale up or scale out. Now, to us, what scaling up means is you add more drives into the servers you already have. And scaling out means you add whole new servers as well. And you can add either one by one. It's completely up to you. In our case, scaling up isn't really going to help me because I have enough storage, actually. What I'm running out of is CPU. So I'm going to scale out by adding a 3rd server. So here I have a server that's exactly the same configuration. It's in my colleague's office now, with 2 NVMe and 4 SSD. And I'm just going to join it to the cluster. When I do that, I'll see it very clearly on the dashboard. It'll show up. I'll see that I now have 3 servers in that server tile. And I now have those 18 drives in the next tile down. I can show you there are the servers. There they are, 1, 2, 3. The next one is named node 1. And I have those 18 drives. Now, this is where we get to do something kind of fun. We've never been able to show this before, but it's a feature we've had for a while. If you go into the drives view, and you look at all of the drives, I'm going to group them by servers here, and you'll see that those 2 nodes, 3 and 4, their drives are almost full. Right? That's the way it was when I first connected this cluster. That new server, its drives are empty. But I don't have to do anything. I can just go get a sandwich and wait. And Windows will automatically, here I'm going to speed the video up for you because this took hours in real life because we're moving terabytes of data. But if you look closely, Windows is moving data off of those drives that were very full and balancing it onto the new drives in that new server. Without me having to do anything, it's just getting them to the same level of utilization. And if you scale out again, it'll do it again. It'll always keep the drives equally utilized. And just like that, these drives that I just added a couple hours ago have about 50% usage, and so do the other drives. That is a visualization that I just love. I don't know about you guys. I think that's really cool. Thank you. Now, I can drill in just to check, and I can see that that new drive is as full as I expect. So there's no funny business here. We didn't Photoshop it. OK, so that's only half of the story, though, right? We just showed rebalancing the storage across all of your nodes after you scaled out. The other half is we have all these VMs on those first 2 servers, and we'd like to redistribute those as well, right? And for that, we have virtual machine load balancing, which is also in Windows Server 2016. You can go try it today. It's there. And that actually takes a little bit less time, and it's a little less visually interesting. But if we go back to our cluster, we'll see that it's happened. So by the way, a point to make is that we throttle all of that, moving terabytes of data around, so it really doesn't impact the workload. Your workload is going to continue to want to run, and you won't really notice this, but it's happened. And now if I drill into virtual machines, and I take a look at that list, I can see that many of them are on node 1, which is the node I just added. A bunch of them are still on node 3 where they were, and some of them, of course, are on node 4, right? So we've taken those virtual machines, and again, I didn't have to do anything. I just had to wait. We've redistributed them across all of your servers to even out the CPU and memory utilization. Next demo. Oh, I like this one, too. We cheekily called this one Get 10 Times More Storage for Free. And it ties into another announcement that we're making at Ignite this week, and that is that deduplication and compression for the REFS file system is available now to Windows insiders. And I'd like to show you what that looks like in Project Honolulu. So in this cluster, I've created 2 volumes. One is named with deduplication, and one is named without deduplication. And that probably gives you a good hint of where I'm going with this. So just to show you what we have inside, if I go into the with deduplication volume, you'll see that I have all of the files associated with those 17 virtual machines that we've been running this whole time. So I have all of their configuration and all those files. I have all of their VHDs. In this case, I've arranged them to be different than the way Daniel had it, but it's close enough. And you can see we've been running a bunch of synthetic workload tools, so things like CPU stress or disk speed, which is our I/O load generating tool. So all the VHDs are different sizes. All the VMs have sort of had a slightly different path to their current state. If I go into the other volume, the one without deduplication, you'll see that I have all of the same files there, too. I literally copy-pasted the exact same set of files from one volume into the other volume. And when I look at it in the file system, I see that it's the same. But if I switch over to the hyper-converged dashboard and I look at my volumes, this is where things will get interesting. Now I can see my volumes in the inventory. There they are, 2 of them, the one named with deduplication and the one named without. They're both REFS, as I promised. And they're both otherwise identical. They're both using 3-way mirror. They're both 200 gigabytes. But what stands out, or what should stand out, is that that one that's not using data duplication is almost full. If we drill in, we'll see that the files associated with these 17 VMs have more or less filled up this 200 gig volume to over 90%. And we have an alert to that effect. And it tells us, hey, the volume's running low on storage capacity. And the suggestion is you should resize the volume, delete unwanted files, or move files to other volumes. Now, personally, I think this alert should say, go get on the dedupe train, you chump, because if you look at the other volume, it is far less full. If we drill into the volume that is using data deduplication, the one named with deduplication, again, it has all of the same files. This is the file path we were looking at in the other tool. But that 200 gigs of data has been squeezed down and compressed by data deduplication and compression to be just 10 gigabytes. Now, this is slightly on the optimistic end because I think our files were synthetic, but we routinely see savings in the ballpark of 80 to 90% with virtualization, with VHDs or ISOs. And in this case, you can take a look in PowerShell and confirm the math that we're seeing 94% savings rate. And honestly, that's not that unusual. So I mean, you tell me which of these looks like it's going to be more affordable, which one looks like it'll require more power, more cooling. So we're pretty excited about dedupe on REFS. OK, with that, back to Daniel for another demo.
All right. Let's switch gears and talk a little bit about disaster recovery. If you're an IT admin, or if your customer is an IT admin in a small or medium business, and you might be running a few physical servers, some of them running virtual machines, One of these days, the server might go down, and along with that, the VMs on top of it. And maybe you're a small shop. You don't have mission-critical workloads. You don't have to be running 24/7. But still, wouldn't it be nice if you could spin up some of the VMs that are more important for your company? Or maybe you're in a central office that's managing a lot of branch offices. In each branch office, maybe you have a 3-node hyper-converged cluster running a lot of VMs. One of these days, one of those nodes are going to go down. Maybe you don't have enough capacity to keep all your VMs running. Wouldn't it be nice if instead of going out with a replacement server right away, if you could keep your VMs running somewhere else until your regular maintenance schedule in a couple of weeks? Well, with the power of Azure and Azure Site Recovery, we're trying to make that easy to replicate your VMs to the cloud. And with Project Honolulu, make that a seamless, easy experience. How does Project Honolulu work with Azure Site Recovery? There are actually 3 steps, 3 simple steps you have to go to. Step 1, configure Honolulu to be able to talk to Azure Site Recovery in the cloud. Step 2, Honolulu will go out and install the Azure Site Recovery agent on all the cluster nodes and configure the nodes so they can talk to the Azure Site Recovery. And then step 3, start replicating your VMs to the cloud. Let's see how this actually works in Honolulu. We're back at the VM inventory tab. You can select a VM, choose more, and there's setup VM protection. And a dialog pops up showing you the 3 steps that I just described. You click on that button, then we'll launch a web page that describes this in more detail. And we have a PowerShell script that you can download or copy and paste. And this will configure Honolulu Gateway to talk to Azure Site Recovery for you. Now, this is a PowerShell script, but we'll be continuously updating and improving Honolulu. And this will soon be part of the Honolulu UI, so you won't have to actually go out and do this through PowerShell. Once that's done, you can close the PowerShell console. Close the dialog, and we'll refresh the UI for you. If you click on it again, click Setup VM Protection, then we'll detect that the first step has actually been done, and then we'll move you to the second step. We ask for your credentials to log into Azure for you. And in step 2, you can see that we've logged into your Azure account. And below that, we have the 4 nodes of the cluster. And we're telling you that we'll go out and install the Azure Site Recovery agent for you. You need to provide a little more information on Azure Site Recovery, your region, the storage account that you want to use, and the Site Recovery Vault you want to use. Now, this is a process that's going to take 10, 15 minutes because we download the agent from the cloud and install it on 4 nodes and configure all the nodes for you. But again, we have the notification pane at the top. It'll keep track of that for you and let you know when it's actually done. So now we're done with step 1 and step 2. Honolulu is configured, your target nodes are configured, and you're ready to start replicating your VMs. Let's see what the actual replication looks like. Choose a VM. If you go to the More button, you can see that it's now changed to Protect VM. And then all you need to do is provide the storage account you want to save it on, save the VM files onto. You get a notification that protection has started. It'll take a few minutes to actually complete. But in the meantime, we can go to the Azure portal and go to Recovery Services Vault. There's the Site Recovery Vault that we just created. And if you go down, then there is replicated items. And you can see there's our VM, and the status shows that it's just started synchronization. And if we go back to Project Honolulu, you can see the VM shows at the end the protection status is now replicating. So in just a few steps, you're able to start replicating your VM to the cloud. Now, this is just the beginning. After you start replicating your VM, if the VM fails over, then there are additional steps that you need to actually fail over the cloud and keep the VM running. But in the future, we'll be making that a part of the entire integration scenario within Honolulu. If you want to learn more, there's a session on Thursday on Azure Site Recovery that you check out. All right, our last demo of the day. And we left the best for the last. I think you're going to like it. So this is the very beginning. We're just starting. There will be gaps, and problems will occur. For example, you might have a server of a cluster node that's acting up, and you might need to reboot it. Luckily, you have the Manage Server button. That'll take you the standalone server experience within Honolulu for that cluster node. On the left-hand side, you see all the familiar tools to troubleshoot and fix your issues. And the top right, we have that restart button to actually reboot your cluster node. We go to devices. This is the familiar device manager view that you've seen from MMC tools. You can go to disk drives, the same disk drives for Storage Spaces Direct that Cosmos showed you. And in this case, we actually show the OS disk as well, because this is the device manager. Right? Go to firewalls, for example. You see all your incoming rules, your outgoing rules, and you have the commands to create a new rule, enable, disable the rules, or delete them if you need to. Now, what if in the UI there's still something missing, something that you just can't do? Well, this has been the top customer request, and I'd like to show you the PowerShell console in Project Honolulu. Now, this isn't just this is the real experience, the full experience for PowerShell console. You get all the color formatting that you expect with a real PowerShell console. You can print variables. That works as well. And for long-running commands like get computer info, we show you the rich progress information at the top. And what can you actually run? All these commands that you expect with a real PowerShell console. All right, this is still work in progress. We haven't released this. We're working hard on it, but this is something that we're really excited about, and we wanted to let you know that we're really listening hard to your feedback and working hard to deliver these new features that you're asking for as soon as possible. So we invite you to join us on this journey of building the future of Windows Server Management together.
OK, thanks, Daniel. So we have one last section here in our last couple of minutes, and that's a quick discussion of what's next, and we're going to try to address a couple frequently asked questions as well. We've been in private preview with about 100 very kind early adopters of our technology for the last couple of months, and they've given us a long list of things that we still need to work on, and we know that is very early for us. Now, the reason that we are taking the hyper-converged experience within Project Honolulu and moving it from a private preview into a public preview is actually a pretty specific reason, and that is that we need your help. We've only been working on this for less than a year, and if I may say so, I think we've come quite a long way. So imagine where we will be in another year. We want to make sure, I mean, it really matters to me that what we build, what we eventually go general availability with, I want to make sure that what we build is what you want, that it's the tools that you need. And to help us do that, we need your feedback. Now, a couple of quick administrivia type related things. Daniel mentioned this at the beginning. You can install Honolulu on Windows 10 or on Windows Server 2016 or later. That's for installing the actual client. You can use it in Edge, as we've shown, or if you prefer, we also support Chrome. A couple of notes on requirements that you might expect. You do not require remote server administration tools. You do not need RSAT. You do not require System Center, and you do not require any of the web app infrastructure that you might have expected, like IIS or SQL Server. None of that is required. However, because Honolulu is in preview, and much of the infrastructure that makes it work is also in preview, you do currently need to use it against a recent insider build of Windows Server. OK, now we've showed you something that is kind of unlike anything we've ever showed before in this space. So it's time to talk about licensing. And the way that we're going to do this, I'm just teasing. Everything that we've showed today is completely free for everyone. So if you're excited as we are, here's what you should do. I encourage you to go join the Windows Insider program for Windows Server. Download Project Honolulu at aka.ms/Honolulu download, and then share your feedback with us. This is the most important one. Share your feedback on user voice. We really are listening. We read everything that comes in. You can get there by going to aka.ms/HonoluluFeedback, and we cannot wait to continue building this with you. OK, that's it for us. Thank you all so very much. You've been a wonderful audience. Please remember to evaluate this session and have a fantastic week at Ignite. Thank you.